Good morning everyone and welcome to the UTS AI Showcase Workshops and Masterclass series. Thank you very much for joining us today. We will do a quick introduction and then get started with the first workshop. Before we commence the first workshop, I would like to acknowledge the Gadigal people of the Eora Nation upon whose ancestral lands our city campus now stands. I would also like to pay respect to the elders, both past and present, acknowledging them as the traditional custodians of knowledge for this land. Welcome again to the Workshop 1 on Deep Learning with Images. Thank you very much Bradley and Dr. Emmanuel from MathWorks Australia for the help and support and kindly agreeing to deliver this wonderful workshop. I would also like to thank the organizing committee members and the student volunteers for all their help and support in making this event a success. As you all are aware that due to the current COVID-19 situation, we have postponed the AI Project Showcase session, which was an on-campus in-person event scheduled today from 4 p.m. to 7 p.m. The new date for the AI Project Showcase in-person event will be announced soon once the COVID-19 restrictions are relaxed. So please keep an eye on the UTS AI Showcase website for further updates. If you have registered for the showcase, you will also receive updates from Humanitics very soon. So, without further delays, I would like to request Bradley to take over this session, and we all are looking forward to the wonderful workshop on deep learning with images. Over to you, Bradley. Thank you very much.
Okay, just a real quick check. Can you see my screen? If you can just type in your response into the chat window. This is a nice sort of segue into just reinforcing that we've got a whole bunch of eyes staring at that chat window. Myself, my colleague today, I'm joined by Dr. Emmanuel Blanchard, one of the application engineers from the MathWorks office. And collectively, we're going to be eyeballing that chat window, monitoring it for questions, any issues. So please do, try and utilize that chat window. And if it's not working for you, or if you really feel that posing a question using audio, please also feel free to do that. So look.
Yeah, good morning, everyone. I'm Emmanuel. I'll be doing that.
Hi, welcome, Emmanuel. So look, thank you first of all to Dr. Nibin Sharma for giving us this opportunity. You no doubt know why you're here. This is going to be a workshop that sort of exposes you to some of MATLAB's capabilities for working with images on utilizing deep learning. We're going to sort of stop this session local Sydney time at 12:15. That's just a courtesy to the next set of presenters that are following immediately after us. So look, we've got the best part of 2.5 hours to sort of have some fun. I'm hoping that you did some due diligence in the registration page and you made sure that you could create your MathWorks account. So really that, obviously, along with having this internet connection, are the only prerequisites for this workshop. So let's start. So you know what? We have, as I mentioned in the intro, we're going to spend the next sort of 2.5 hours looking specifically at deep learning with images. But I'd like to sort of take, if I may, just a few moments just to remind you very quickly, 7 minutes or less, of some of MATLAB's capabilities in traditional, in quotes, machine learning. And the reason that I want to start this session with this apparent sort of branch is most people that are interested in deep learning applications have more than a passing interest in traditional machine learning. So if you can just indulge me for 7 minutes, I'd like to sort of do some warm-up stretches and just show you real quick what MATLAB has to offer in traditional machine learning. And then we'll rewind and then start on our deep learning with images. So here we go. In 7 minutes or less, let me show you what MATLAB has to offer in traditional machine learning. So as a case study for this, what we're going to do is we're going to develop a pattern recognition solution, a classifier that specifically diagnoses tumors. And those tumors are either going to belong to the malignant class or the benign class. So if I can, I'm going to load in to MATLAB using this live script, just the measurement data, the already known and labeled responses, along with the corresponding feature sets that accompany this measurement data set. So to give you a little bit of orientation, here's a MATLAB table on the right-hand side of the screen, and simply remind you that the response variable for this case study is that the tumor diagnosis. M stands for malignant, B stands for benign. And then the sort of remaining sort of 30-odd columns for each of these rows that corresponds to a tumor, they're our feature columns. And these represent sort of features that were computed from digital images, things like the average perimeter of all of the tumor cells, the average smoothness, the concavity of those cells. So look, we have a table that contains all of our measurement data. And what we're going to do is we're going to do the standard workflow of partitioning that data into a designated training table set. It gives us around about 342 of those tumor samples. And we will reserve 227 of those tumor samples specifically just for testing. So that's the background. Let's get into it. So a big part of the modern MATLAB experience, obviously MATLAB is a language, but a big part of the MATLAB user experience is more than just writing lines of code. Being able to rapidly prototype and explore an idea before you commit to coding is one of the sort of benefits of MATLAB. So what I'm looking at here is just a list of all of the available technical computing apps. We have many in controls, in signal, and computer vision, and we have a whole bunch in machine learning. So the particular app that I'm going to launch today in this case study is the Classification Learner app. So let me sort of give you a quick 2-minute demo of what the Classification Learner app looks like. And here it is. So the app, it's quite intuitive. Let's start with a new session. And it's going to give us the opportunity to load in our training data set. So out of the partition data set, we have a test table. We're going to use the train table, obviously, to do our training. The heuristics built into the app has immediately recognized that the diagnosis column in that table is most likely the response variable, and it is. So I won't override that. On the predictor side, I'm going to retain all of the remaining columns except for the patient ID. At the moment, the identity of the patient is not something that I really think is important. So yep, let's bring that data in. And there it is. And the app gives you access to around about 30 sort of different algorithms for designing these classification sort of solutions. Decision trees, support vector machines, obviously shallow neural networks. Now, right now, if you don't exactly know which of these particular algorithms is going to be most effective for this specific data set, then the only sort of logical sort of choice is to choose all of them. And that's exactly what we'll do. So I'll click all. And now when I click on the green train button, the app is going to manage and queue a training task for all 30 of those machine learning algorithms. So at the moment, it's going through the process of queuing, and very, very soon, you'll see the sort of status update of each of those model creation exercises. So the app is now sort of working through, and you can sort of see that as it develops a model for each of those 30 different algorithms, it also does a shout out to the algorithm that has the current best performance. So it's sort of working through, we're down to the 20-second sort of algorithm that it's developing a model for. We're now onto the sort of last handful, and look, we're done. So in one click, we've been able to generate 30 different machine learning models. And as I just sort of scroll up this list, the one that apparently, for this data set, that had the best performance was one of the support vector machine variants. So let me just sort of click on it. You can see that it's been able to produce, at least for the training data set, an accuracy of about 98%. Obviously, accuracy is only one sort of lens for assessing performance. The confusion matrix is perhaps a better one. And if I sort of light up some of these radio buttons, you can get a sense for what the recall percentage is, or even the precision percentage. So there you have it. We've just sort of reviewed 30 different machine learning algorithms, and apparently this support vector machine variant is the one that is showing most promise. From here, just before I sort of close out the app, there might be a number of things that you'd like to do. Maybe you'd like to export the model into MATLAB. Alternatively, at this stage, you might decide this is the moment that you'd like to commit to coding, and this is where you want to transition from an interactive, exploratory sort of user experience to a programmatic user experience. And the app sort of helps you get started with that as well. Within the app, there's this nice generate function button. And true to its word, it automatically generates today the corresponding MATLAB code for producing that particular support vector machine variant that we clicked on. So it gives a nice sort of bit of insight into the low-level functions that produce these machine learning algorithms. So the final sort of part of this example is for a lot of our customers, once they develop these models, they typically like to then sort of move on towards sort of deployment. And deployment can mean different things to different people. So the particular deployment sort of story that I want to quickly finish with is deploying to silicon. So the workflow for transitioning from having created a MATLAB solution to converting that MATLAB solution into a form where it can be deployed to standalone silicon. Well, we provide a code generation as the solution pathway. So it involves translating MATLAB objects, MATLAB functions, into standalone C or C++ code. So it's a really sort of simple sort of workflow. Let me sort of really quickly sort of show you what that looks like. The solution again has a programmatic sort of solution, but the sort of apps again sort of come to the table. So we have a whole bunch of tools that end with the word coder, and that's kind of a signpost to the fact that they convert MATLAB things into standalone C, into standalone HDL, into standalone CUDA. So for this traditional machine learning example, I'm going to use something called the MATLAB Coder. Yeah? And the workflow looks something like this. So the first thing that I do is I select the top level MATLAB function that is the thing that I want to convert into standalone C. The next step in the workflow is to designate the input argument attributes for this designated function. And a really nice way of doing that is by creating a test harness. So let me just sort of click on the test harness. And what the test harness allows me to do by example is to specify the input argument attributes, the data type, the sizing. And if this is not what you want, then you have the capacity to override those input argument attributes, in the app itself. Let me sort of click through to the next step. I can skip over this one because I really want to sort of cut to the chase. And just before we hit on this magic sort of generate code button, there are many sort of configuration settings that you can specify in order to produce the style of code that you particularly want. Yeah. So, for example, I think putting in the original MATLAB source code as comments is one. Giving thought to whether or not you want to use dynamic memory allocation is another really good example. We have a lot of customers from the automotive industry that use these code generation tools. And for them, the MISRA coding guidelines is something that is important to them. And we've built that directly into this coding product. So I can pretty much say, yes, all of these important MISRA guidelines, let's adhere to them. So after you sort of select and choose what's important to you, then it's as simple now as just clicking the Generate Code button, and Matlab Coder will go away and start with all of your designated top-level functions. I only picked one today, and for all of the code dependencies that those top-level functions have, it will collect them all and convert all of them into standalone C code. And here's a software sort of report that allows you to do a line-by-line comparison between the original MATLAB function on the left and the corresponding C code on the right. So there you have it. I know that was a really quick sort of walkthrough, but again, I just wanted to give you a feel, a teaser, if you will, that in traditional quotes machine learning, MATLAB has a lot to offer too. Okay, let's get back on track for our workshop. Alrighty, so look, our first step is an interactive one, and what I need us to do is to take just a few minutes to sort of get set for the workshop. So what we're going to sort of walk through together is the steps involved for you to get access to the example files that we will be using inside MATLAB Online. So today, you'll all hopefully be participating through MATLAB Online. So it's the version of MATLAB that runs in your web browser. So what we need to do is we need to firstly do a couple of steps that transfers the example files that you'll be playing with. And then secondly, we need to make sure that you log in to a very specific version of MATLAB Online. I say it's special because we've reserved some cloud GPUs, which you're going to need to use as you work through the deep learning exercises that we do together. So before I sort of walk through those steps, just a shout out. Look, Google Chrome, it's the recommended web browser for today. You can still do the workshop if you're not using Google Chrome, but there are certain components of the workshop, in particular using this thing called the Deep Network Designer. It's an app that is only currently supported in Chrome. So if you're looking for a conclusion, I highly recommend to you all that you use Google Chrome today for this workshop. Okay, so in just a moment, I'm going to post into the chat window a Dropbox link. And that Dropbox link will contain a PDF file that effectively is what you're seeing on screen right now. So there are 3 steps that you need to follow, steps 1, 2, and 3. Let me just show you what those steps look like. There's no mystery. And when you get your hands on the PDF document, you'll be able to click on these hyperlinks that are on screen. But just pause for a moment and just give me 1 minute and I will show you what this looks like. So step number 1 involves launching MATLAB Drive, and that's accomplished by just sort of clicking on this particular sort of URL. So when I click on the MATLAB Drive icon, it automatically logged me in, which is not something that I wanted it to do. So you'll get to a screen that looks like this. And this is where you type in your MathWorks account details. Yeah. So for me, I'm going to type in my MathWorks account credentials. I'm going to type in my password. And here is my MATLAB Drive. This is my cloud drive where I can sort of upload files to, and it is the drive that MATLAB Online will have access to. So that's step one. So just log in to your MATLAB Drive. Oops. Step two is clicking on this particular link. So this is actually someone else's shared MATLAB Drive folder. And it's specifically the folder that contains today's exercises. So let me just sort of click on this guy. And when you perform step two, it looks like this. And once you get to this shared drive, it's as simple as going to the add to my folders and choosing copy folder. So this is having chosen copy folder, you have now successfully copied all of those exercise files and folders to your MATLAB Drive. So this is step two. So that was step two. Step three is then launching the very special MATLAB Online link. Now, I just want to get ahead of the curve here, particularly for those of you that are already familiar with MATLAB Online. Do not go into autopilot and log in to your traditional MATLAB Online. If you do that, you will not have access to the cloud GPU resources. So it's really important that you all click on this very special link. This is our MATLAB Online workshop link, and that's the thing that you really need to access. Okay, so look, really this should be doable in a minute or so, but we'll sort of budget, let's say 5 minutes. So let me just grab the Dropbox link, and I'm about to paste it into the chat box. So if you can just eyeball that chat box and download the PDF document. It should have all of these links that are on screen right now. And I just want you to walk through steps 1, 2, and 3. So look, let me be quiet. I'll be monitoring the chat box for any issues. But yeah, let's see if you can all get this done within sort of 5 minutes. Hey, Emmanuel, just a quick check-in. My shared desktop, you can see the setup instructions, part 1 of 3 on screen.
Yes.
Yeah, oh, great. Folks, if you've already done this, can you just give me a little bit of feedback in the chat box just to say setup done, just so that I've got a feel as to how everyone's progressing. Thanks, Aidan. So as I said, I'm just going to sort of give everyone a good solid 5 minutes to sort of work through this, which I think is more than enough. So. Thanks, Haley. Thanks, Min. yeah, it looks like, well, a lot of you are sort of acknowledging you've been able to sort of complete these 3 steps. Great. So let me just wait out just 3 more minutes. Just a little bit of sort of cocktail party trivia, just while we sort of wait for the clock to sort of count down for everyone. MATLAB Online has been around since about, I think it's 2016. It's been around for quite a while. But you know, a recent sort of advancement in MATLAB Online is it now supports Simulink, for those of you that know what Simulink is. It is almost feature parity with the core product, that just MATLAB. There is a documented sort of a bullet point list of things that don't exist in MATLAB Online, which do with the MATLAB Desktop version. At the moment, only about 30 to 40 of the Toolbox libraries are supported in MATLAB Online versus about 80 or 90 on the desktop version. So it's not quite full 100% feature parity with the local desktop version, but it's still a very, very useful piece of kit. Yeah, look, Ian, I feel your pain, your post about having issues logging into that workshop MATLAB Online link. I actually experienced that identical problem myself this morning. So it took me, without exaggeration, it took me about 1.5 minutes for me to finally get through. So for those of you that are also seeing that, look, wait 10 seconds and try again, yeah, just keep trying to push through that sort of login. That's the best piece of advice that I can give you. All right, thanks, Nin. All right, so look, we're coming up to roughly the sort of 4-minute mark. So Salim has finished. Thanks, Salim. So quite clearly, some of you are still sort of getting through, but I don't doubt for a moment that a handful of you are probably getting sort of stuck and being asked to try again in 20 seconds, 40 seconds. Okay, so look, I'd like to sort of move on if I can. So the second part of the setup process is I'd just like you to confirm that in your MATLAB Online, you can see a folder called Deep Learning Exercise Files. And when you sort of expand that particular folder, you should see that it contains 8 subfolders. So I'll just get you to confirm that you can see that. The next step is in your command window, I'd like you just to type in the command GPU device. And hopefully that confirms that you really do have access to one of our reserved cloud GPUs. So let me just sort of show you what my sort of MathWorks, what my MATLAB Online for this workshop looks like. Here is the deep learning exercise files folder. All right, so let's sort of take this as a moment to try and get familiar with the MATLAB Desktop. All right, and if you see anything unusual in your MATLAB Desktop, please type something into the chat. But look, for those of you that are brand new to MATLAB, let me just sort of give you a tour to some of the relevant pieces. So if you sort of look at this sort of part of the screen, this gives you your present working directory folder breadcrumb. All right, so the root folder for you is called Matlab Drive. And you can sort of use this sort of breadcrumb to sort of pick, whatever folder you now want to navigate into. So I'm just going to sort of click on this little sort of drop down sort of box and say, look, I want to navigate, change directory into the deep learning exercise files folder. All right, and you can sort of see the present working directory folder breadcrumb, and you can see that this is the contents of this folder. Now I don't ordinarily get into the habit of airing dirty laundry, but I want to table it because this particular sort of bug did occur on Thursday last week, and we've got our sort of development team rolling out a patch for it very soon. Some of you, I'm hoping none, but it's quite possible that some of you may not see anything in this current folder sort of panel. It's completely empty. If that is what you see, then the way to work around it is to do this. Click on this little sort of icon in the current folder panel and make sure that under the group by submenu, you do not have type checked. In fact, just make sure all of these group by checkboxes are unticked. You'll have to do that. And then you'll need to do a browser refresh and then navigate back into the folder. So it's a real hassle, and it's horribly inconvenient, but I'm just putting it out there that this might be the behavior that some of you are seeing. If it is, let us know in the chat box, and we can make sure that someone sort of guides you through what I've just described. Okay, so finishing off setup part 2 is I'm just going to type into the MATLAB command window that command GPU device. And I'm going to hit enter. And if you see sort of an echo that looks something like what's on my screen, then awesome. That means that you definitely have access to one of these cloud GPUs that we're going to be utilizing. Just as an FYI, I reserved 90 of these with the expectation that we'd have 90 attendees today. All right, so that's the second part of the setup. The third part of the setup is really just an FYI. All right, there's no action for you to take. It's just a little bit more of an insight into where a lot of the data sets that will be used today. So as an FYI, in your MATLAB Drive, there will be a folder called Workshop, a subfolder called Deep Learning Workshop, and then another subfolder called Large Files. And it's inside this large files folder where a lot of the data sets that we'll be using today exist. You do not need to do anything with this at all. I'm just letting you know that that's how things are. Ian, to me, that error message seems to be indicative of you not having logged in to the special workshop MATLAB Online. Did you log into your traditional MATLAB Online? So that's, yeah, yes, thank you. So yes, if you log into your traditional MATLAB Online, you will not have access to the GPUs. You have to use that workshop link. Okay, so look, again, just a little bit more FYI, 99% of the functionality that we're going to be utilizing today comes from our deep learning library. And we use the term Toolbox at the MathWorks instead of the word library. So we have this thing called the Deep Learning Toolbox, and it's a library that contains, over 230 sort of functions for helping you develop deep learning applications. And like most of our products, jam-packed full of shipping examples that you can use as starting points, to explore and get some familiarity and confidence with. So we're going to be using the Deep Learning Toolbox extensively today. Having said that though, and I've already sort of given you sort of a bit of a heads up with that machine learning quick demo, but we've got quite a few sort of products. So at last count, it was something like 80 to 90. And I've sort of lit up in red a lot of our libraries that are associated with machine learning. So we have our vanilla statistics and machine learning toolbox. We have the deep learning toolbox, which we'll be using today, and we have the reinforcement learning toolbox as well. We have a lot of products associated with image processing, and we have a lot of products that allow you to convert MATLAB world things into standalone world things, CUDA code, HDL code, C code. Another barbecue sort of trivia fact is that there's approximately 40 universities in Australia, and there's approximately 8 universities in New Zealand. 33 Australian universities and 6 New Zealand universities have this thing called the MATLAB campus license. And that is full access by every student for every product on every computer, personal and also campus. So I'm just throwing it out there that, MATLAB is accessible to almost everyone in Australia and New Zealand in terms of tertiary institutions. So if you didn't know that, well, that's an interesting fact. All right, folks, let's get into this, okay? So let's start this, this hands-on deep learning workshop. So here's the agenda today. We're going to spend the bulk of our time on product, using the product to work out our way through a series of exercises. In total, there's 6 exercises. I think as a goal, we should aim to trying to complete the first 4. So we'll start off really slow. We'll do some warm-up stretches and again, try and get you a bit more familiar with the MATLAB interface for those of you that are new to it. We'll introduce you to one of our fundamental file management concepts. And then after those preliminary sort of warm-up stretch exercises, then we'll move on to what I'm loosely referring to as the interesting exercises. We'll show you how to develop deep learning applications. We'll start with the classic MNIST handwritten digit classifying problem. Then we'll move on to that all-important transfer learning sort of problem in the workflow. So that's what we're going to be doing, yeah? Okay, so I'm guessing that you all know that, the attractive thing about deep learning sort of neural networks is that you're able to present to them the raw data, because the networks, not only do they have that classification part of their structure, but built in to these deep learning networks is the mechanism to try and extract features from the raw data. So the deep learning network has that feature extraction capability as well as the ultimate classification capability. And that's real rough distinguishing attribute of the deep learning sort of networks versus the traditional shallow networks. The deep learning workflow, it obviously has a whole bunch of steps, cleaning data, labeling data, creating the models, using the models to simulate and test, and ultimately deployment. So today in this workshop, we're going to focus predominantly on the model creation part of the workflow. Look, I don't need to tell you guys that, AI in general over the last sort of 15, 20 years has sort of, exploding in terms of interest and in terms of application. And, we have many sort of industrial sort of customers that are applying AI in their products. But you know what? A lot of you are probably coming to this workshop today as members of two distinct groups. I'm guessing that a lot of you are already machine and deep learning practitioners that aren't using MATLAB. So I'm glad that you've come along today to sort of find out what's on the other side of the fence. And I'm guessing also there's another group of you that are current MATLAB users, and perhaps you've come along today to see again what can MATLAB do for deep learning. So a comment that I'd like to sort of leave you with is that most deep learning applications are never just about deep learning. That deep learning is part of a larger project, a project that involves control system design, a project that involves computer vision, a project that involves LiDAR and audio. And because of this AI plus many domain, specialty areas, it's because of this that MATLAB does have an advantage. MATLAB is very good at signal processing. It's very good at radar system design and audio processing. And you know what? Over the last 10, 12 years, it's been progressively building up its capabilities in machine, deep, and reinforcement learning. So I hope that this AI plus domain specialties is a message that is something that is of interest to many of you. Alrighty, so let's get into it. All right, enough talk. Let's jump into the very first warm-up stretch exercise, and let's walk through this together. So the starting point for everyone is if you can navigate into your deep learning exercise files folder, and then from there choose folder number 1, getting started. So if you can just sort of follow along with me. We've got eyes on the chat box. Please take the opportunity to say slow down, miss that. If you don't type it, we're not going to know it. So nice and slow, if you can just sort of get yourself here. So once you've sort of navigated into this folder, if you can just sort of eyeball that you should have 2 files. One of them is called work, getting started. And that's the file that we're going to play with, excuse me. And the other is called solution. And you'll actually see this pattern in all of the exercise folders today. We will have a work script that is meant to be the thing that you can work on. It's partially completed and you just need to fill in the gaps. But if you fall behind or if we're not able to address your specific query, rest assured that there's the solution file that you can also consult and sort of have a look at what that missing step was. Okay, so look, let's start by opening the work getting started file. So that's as simple as clicking on the file and then right-clicking to bring up the context menu. And then once the context menu appears, just select open. And what this is going to do is it's going to open up a MATLAB script. Okay, and here it is. So right now, I'm kind of guessing that this is the default sort of layout that you're sort of seeing. And what I mean by that is you'll see that we've got the script file is open, and more than likely on your machines at the very bottom of the script, you have this thing called the command window. And you know what? It's taking up screen real estate for me. So I'm just going to click on this command window panel, and I'm just going to sort of slowly move it to the left so that the panel is now docked on the left-hand side of my screen. And the reason that I've done that is it now sort of gives me just a little bit more screen real estate to look at on the script. Yeah. Okay, so look, let's work through this getting started script. All of these MATLAB scripts have been partitioned into sections. So what I kind of mean by that is that when you stare at the scripts, you'll see that throughout the scripts there are a whole bunch of these blue lines, and these blue lines indicate that that there are chunks of code. We call those chunks of code sections. Yeah. So the significance of these sections is that you can position the cursor anywhere in the script by just clicking in a section. And when you click in a section, you'll see that on the left-hand edge of the editor, it sort of lights up the left-hand edge in a light blue color to indicate that that is the current selected section. So just have a bit of a play with that. So right now, I'd like you to click in the very first section of the script. All right, so just click anywhere in the section and just confirm that this really is the section that's been clicked on by confirming that you've got this light blue sort of bar. So what we're going to do now is we're going to only run sections one at a time. So again, if you can just sort of pause and just soak this in, you'll see that in the live editor, we have this big green run icon. And for the most part, I do not want you to click on that big green run icon, because that will try and run the script in its entirety from top to bottom. Instead, the workflow that we'll be following will be to either run a section, which as its name suggests, will only run the section that you've currently clicked in, or alternatively, you can accomplish the same run section outcome by positioning the cursor over the light blue bar on the left-hand side, and you'll see that the cursor changes from a pointer to a finger. And as soon as you've got that finger icon, you can click on the blue bar. So I'm going to do that now, and I'll get you to do the same. So having clicked on that blue bar, you'll see that little circular throbber. So let me do that again. So that circular throbber appears telling you that MATLAB's thinking, it's trying to run, and as soon as it has actually run that section, it'll stop. So this first section that we've just run, what it's done is it's just loaded into MATLAB a predefined deep neural network. And it's one of the sort of early pin-up poster boys of the deep learning sort of community. So back in the day, look, I think it was maybe 2017, maybe 2015, AlexNet was one of the first real big success deep learning networks that performed very, very well on some of those classic image classification challenges. So what you've just done in executing this first section is we've just defined an AlexNet deep learning network. So let's now sort of move on to the second section. The second section is called Classify Images of Peppers. And there's about 4 things that we're going to do here. So just follow along. So the first thing that we're going to do is we're going to load into MATLAB one of these example images that ships with MATLAB. It's the Peppers image. So some of you may already know what the name of the read function is for reading a digital image. For those of you that are super new to MATLAB, it's called IMRead. Yeah. So this little code snippet, I'm going to assign the result of the IMRead function to a MATLAB variable called capital I. MATLAB is case sensitive. So, you know, when I say capital I, make it a capital I, don't make it a lowercase I. So the input argument for IMRead is simply the name of the image file that you want to read. And again, I'd like to call out, you know, a pattern that you're going to see sort of, you know, often in these examples, is that for string inputs, you have actually two choices. You can designate a string as a character array, and that's indicated by the use of single quotes. So you can type this right inside here if you want to. But MATLAB also supports this alternate data type called strings, which utilize a double quote. So that's what I'm going to use to sort of type in peppers.png. So you can use either. Now, for those of you coming to us today from a Python background, I'm sorry to say that you will need to include a semicolon at the very end of all of your MATLAB statements. Because if you don't type in, excuse me, that semicolon, the MATLAB's default behavior is to just echo the results, you know, into the output panel or into the command window. Sometimes you do want to see that echo, many times you don't. So I'd like to sort of all encourage you to make sure you terminate your expressions with that semicolon character. Okay, so the next piece of code that we're going to do is we're going to display, you know, what does this Peppers, you know, image look like? So the sort of syntax for doing that, look, I'm going to sort of request that we have a designated figure container ready to sort of accept some of our plotting commands. And then I'm going to issue, I'm going to call the IMShow function. So IMShow and specifying the name of the MATLAB variable that contains the data of our image. So look, this is probably far enough. Let's see if you've run into any problems with these two really simple lines of code. So you're obviously in this section, so it's the currently selected section. You'll notice that because I haven't saved the file, you're getting this nice little sort of affordance sort of shown on that blue bar. It's gone from being a solid blue bar to a cross-hatched sort of blue bar. And that's fine, that's fine. So all you need to do is just walk up to that cross-hatched blue bar, and as you did before, just click on it. And that will run all of the code just in this section. So let's see how that pans out for you. So I'm hoping, really hoping that you've all been able to display the classic Peppers image. Yep, great. Now, just before we go any further, just a little bit more orientation with regards to MATLAB's editing tool. So if you look on sort of the far right-hand sort of edge of the editor, you'll see these three icons. And these three icons control how the script is displayed to you. So there are three choices. Today, I'm only going to talk about the first two. So one way of having the script presented to you is in serial format. And what I mean by serial format is you will have the code of the script here, and any outputs that are produced and echoed will appear immediately below the block of code that produced it. So this is what I'm referring to as the serial presentation format. Some people like it, and you know, it's horses for courses. The alternative to this serial display format is if I get you to sort of walk over to the top icon on the very right and just click on it. it shows you the parallel or side-by-side display format of the script. And hopefully, as you're seeing on your own machine, what it does is it sort of displays the code on the left-hand side and the output in a separate panel on the right-hand side. So they're the two different display formats. Yeah. All right. So look, let's get back to the section and let's kind of finish off this particular sort of hello world problem. So the AlexNet that we created in step 1, it expects to receive an input image of a particular shape. So this is a really nice opportunity to sort of show you one of our sort of I guess you'd call them sort of summary dashboard sort of tools that are part of the deep learning toolbox. So I'm just going to get you to copy this particular piece of code, just this code right here. Just copy it. Can't do that. All right, let's do this the old-fashioned way. I'm going to go to my command window, and I'm just going to type in Analyse Network, and I'm going to specify the name of the MATLAB variable that we created, which stores the AlexNet. And the name of that MATLAB variable for us is just this thing called net. So Analyse Network and the name of the network that we want to analyze. And if I hit enter in the MATLAB command window, just to run that command, here is a summary of what this particular deep network looks like. So what you're sort of seeing on the left-hand side is a listing of all of the layers in this series network. So at the very top of the network, you have the image input layer. And you'll see that the image input layer requires an image that is 227 pixels wide by 227 pixels high, and it's an RGB or a 3-channel image. Yeah. So AlexNet has what I think it's 25 sort of different layers, in the network. So look, we'll be sort of coming back to this Analyse Network sort of figure, during the course of the workshop today. But the sort of very first sort of application that I just want to sort of, give a call out to is that if we're going to play with one of these predefined networks, we need to sort of, understand that, the shape of the input needs to be of a certain size. So what that means for us, given that that our peppers image is 384 by 512 pixels, we need to resize this peppers image before we can start pushing it through our AlexNet network. So that's going to be our third sort of one-liner sort of coding step. So if I just type in I2, I guess you could overwrite I if you really wanted to, but I'm just going to say I2 is equal to IMResize. So IMResize is the name of a function in MATLAB that will resize an image. So the sort of calling syntax for image resize, don't you just love the sort of sort of syntax hints? I mean, I guess a lot of development environments have that these days. You would expect MATLAB to have it. So the first input argument is the existing image matrix I, and then you've got a second input argument, which is just a vector that specifies what the width and height is. So let me just sort of type in what we need to. So I is the name of our existing image matrix, and 227, 227 is what we need to type in to designate our appropriate resizing output. So don't forget the semicolon. Don't forget the semicolon. And why don't you, again, just to make sure there are no problems with what you've just typed in, run the section again and confirm in the workspace panel that you really have created this variable called I2. And just confirm that it really is a 227 by 227. And it will obviously be a 3-channel image. So I'm really hoping, folks out there, that when you have run our section, that what you're now sort of seeing in your MATLAB workspace panel is this nicely resized image that is exactly the shape that our AlexNet is expecting. Okay, and that just leaves, well, finally, we're at the stage now where we can sort of ask this particular deep neural network to try and tell us what this thing is. So the very last line of code for this hello world example is to say, this is a what? So that's the result that I'm going to capture the output into. And we're going to use the classify method, which is one of the methods that this AlexNet object has. So classify is the name of the method. We now specify the object. Yes, for those of you that are Python guys, we could have said net.classify. We can do that too, but let's just stay on course. The first input argument to the classify method is the name of the object, which is net, followed by the image matrix that we want to perform the classification on, which for us is this thing called I2. I'm going to not put a semicolon at the end of this line because I want to see what it says. So just finish off this very first warm-up exercise by just typing in this final line. And then once you've done that, click on this blue strip on the left-hand side to run the section. So I'm doing that on my machine right now, and because this is the very first time, you'll see that the throbber is really throbbing. Subsequent invocations of classify will not take nearly so long to do, but you'll see that circular throbber is indicating that MATLAB's loading in components, and then it's running this classify sort of method. So please do try and run this yourself. You'll likewise probably take a good sort of 30 seconds for this first run to finish. Yeah, just again checking in with Ian. Unrecognized function or variable net. Again, to me that gives an indicator that that perhaps you've logged into your normal MATLAB online and you haven't logged into the workshop MATLAB online. So just see, and if you can sort of keep chipping away at trying to get into that special designated workshop MATLAB online link that was in that PDF document. Okay, well look, just a bit of feedback to me, if you don't mind. Did you all sort of get an output of bell pepper? That apparently this picture has been classified as a bell pepper. Thanks, Sandra. Thanks, Gitara. Yep, Fantastic, fantastic. All right, so look, really all I wanted to do in this very first exercise is to get you comfortable with the MATLAB Desktop, opening up a script, being able to click into a section, being able to just run just that section. All right. So really, that was the main purpose of this very first exercise. All right. So let me get myself sort of primed and ready for the next exercise. So let's just navigate into the folder that's called 2-models. So if you can just sort of go to your folder breadcrumb and click on deep learning exercise files, and then choose this guy. All right, so just let's establish that everyone is in the right place. So hopefully your folder breadcrumb looks like this. And if you get yourself to this location, you can just again confirm that it looks something like that. Okay. You know what? Unfortunately, we've still our workspace is still containing all of the remnants of our very first exercise. So look, I guess you've got a couple of ways of sort of deleting all of these sort of variable sort of artifacts from exercise 1. If you're interested, the command that you need to type into the command window is called clear. So that's one technique. Just type in clear and hit enter. Another technique is you can just interact with the workspace sort of panel. Select the top, hold down the shift key, go to the bottom, and then you should see an icon on the home tab sheet, clear commands. Clear workspace. So this is another technique for deleting variables in your workspace. So I guess what I'm trying to say is, pick your poison, type in the command clear or click on that icon, because I'd really like us just to start with a really clean slate, if that's possible. Okay, let's set up the sort of second example. So in just to wrap up the first one, here's what that very first Hello World script did for us. There was an image file called peppers.png. We read that into MATLAB using our script. We had to resize it into a certain shape that our pre-trained AlexNet network required. And then we use the classify method that belonged to that AlexNet object to try and classify, what that image was. And most of us were able to sort of see that the classifier thought that this thing was a bell pepper. All right, so that was exercise 1. So just some commentary to sort of get us in frame for the second exercise. You can start from scratch to sort of build your own deep learning networks, and we will do that in exercise 3. But often it's nice to be able to not start from scratch and to instead start with some of these recognized, well-tested, well-recognized, high-performing example deep learning networks. All right. And you'll be pleased to know that in MATLAB, there's of the order of about a dozen or so of these pre-trained networks. AlexNet, GooglyNet, a bunch of the ResNet CNNs, a whole bunch of them. And you can access those pre-trained networks directly from MATLAB. You saw us do it in that Hello World example where we accessed an AlexNet. So for those of you that have come along today from a machine learning environment that isn't MATLAB, you might be using some of the popular open source environments, predominantly Python based. You'll be pleased to know that we've developed a bunch of converters and importers. So we have importers for Keras and Caffe, which is nice. So if you've got deep learning networks from those frameworks, you can import those models directly, into MATLAB. But a much more generic capability, which is almost universal to everyone, is that we have an open neural network exchange importer and exporter. So what that means is that if you're collaborating with someone that has already made a deep learning network in PyTorch or TensorFlow, you can ask your colleague to export that network to the ONNX framework. And then that exported ONNX file can then be imported into MATLAB. And then you can start using that deep neural network. And it goes the other way as well, is that if you as a MATLAB guy have developed and trained a particular sort of deep neural network, you can export your MATLAB network to an ONNX framework file. And then your colleagues can then import that ONNX framework file into their Python-based framework. So that's really good to know, right? It's really good to know. Okay, so look, let's jump straight into the second exercise. And in this second exercise, we're going to have another go at playing with some of these really high-performing pre-trained networks. But the new thing, there is a new thing to come out of this second exercise, and that is I'll give you an introduction to one of our file management concepts that is used within the deep learning workflow. They're called data stores. All right, let's jump into this second exercise and let's have a look. So again, this should be your starting location. And what I'll get you to do is to open up this file, the working file. So I select it, I right click, and I just choose open. Okay, so here's the partially completed work script that together we're going to sort of work through, okay? So as I just sort of scroll through it, let's get into the first sort of section that has some code that we need to execute. So I'd like you to just sort of click anywhere inside the section called Navigate to Correct Directory. I just want you to click anywhere there, and then once you've clicked inside this section, just click on the blue bar to run it. And if everything is good for you, then you should see a little message that says, yep, you're definitely in the right folder. Everything should progress nicely from here. Alrighty, so let's scroll down the script to the next section. The next section is called Choose a Pre-trained Network. And you can sort of see here that we've got obviously some interactive widget. It's just a Dropbox. And you can choose, whatever network you'd like to play with. I'm just going to choose GooglyNet, all right? So you can choose, say, GooglyNet. And you'll sort of see in the workspace panel, after running that section, so please do click on your blue bar. After running that section, we've created a MATLAB variable called net. And this MATLAB variable contains an instance of this GooglyNet network. You'll see that in the workspace panel, we're able to confirm that MATLAB variable really does exist. And that MATLAB variable is just also indicating that this is an example of a directed acyclic graph network object, right? So that's the class of this, this object. All right. What I'd like to do is I'd like to invoke that Analyse Network command just to have a look at what this googly network looks like. So if I go to my command window, right, and just either type it in again or use the up arrow keys to find, you know, where it was that you typed it before. But I just want you to go to your MATLAB command window and again type in this command and hit enter. So when you do that, it should launch that Analyse Network figure that again gives you a summary view of what the network structure of this googly net looks like. And here it is. You can kind of see that it's just a little bit more sophisticated than the series network that AlexNet was. You can sort of see that, say, GooglyNet has a whole bunch of sort of branched, sort of parallel layers that all sort of come, you know, come together at various sort of nodes. I guess from our perspective, you know, right from the get-go, something that we really need to be wary of is the GooglyNet network requires an image to be of the shape 224 by 224 by 3. All right. So, okay. So if you chose GooglyNet, this is what a GooglyNet network looks like. It has apparently 144 layers. Yeah. All right. I think we're done looking at this figure. So that was nice to know. So let's move on to the next section in the script. And that section's called Inspect the Network. Yeah. So this thing called net, which is an object, you know, many of you are comfortable with the fact that, you know, objects have methods. You've already seen us use the classify method. It also has sort of, you know, attributes or properties. So this net object happens to have a property called layers. And we can just sort of type in, you know, using this hopefully familiar sort of syntax, object name dot, you know, method name or property name. And we can leave off the semicolon and it will echo, you know, the contents of this particular attribute. So let's execute this section and just see what happens when we echo, you know, net.layers. So when we do that, so don't forget to hit the blue bar on the left. When we run this section, you'll see that this is the echo that we're getting. And it is familiar to us, given that a few minutes ago we were looking at the Analyse Network figure. And it's just simply reminding us that GooglyNet has 144 layers in its network. Yeah? And in this sort of display, you're also getting some useful information. You're getting a summary of what that particular layer is meant to represent. Layer 1 is the image input layer. This is the expected image dimension. You can see that layer 2 is an example of one of those two-dimensional convolution neural network layers. Layer 3 is an example of an activation layer. And look, we'll be talking more about these specific layers very, very soon. But this is an example of the echo that you get when we query the layers attribute. Let's just scroll down the script to have a look at the second output. So this is worthwhile just stopping and staring. So we've already established by way of the previous sort of line that layers is a 144 element array, right? It represents the 144 layers in the model. Now we could have typed in 144 to say, hey, I'm interested in just knowing a little bit more about that last layer. But in MATLAB, you can use the keyword end, and that's synonymous with the last element in a list. So net.layers.end says, look, I'm curious to know what more information about the last layer. And it just so happens that that last layer was a classification layer. And one of the attributes of that classification layer is an attribute called class names. And it simply lists all of the labels that this particular deep network has been trained specifically to identify. So this googly network has been trained to recognize 1,000 different images. Yeah, and that list of 1,000 image types is echoed on screen. Okay, all right, so let's move on to the next section of the script. And what we're going to do is, to some extent, a rehash of what we did in exercise 1. So there's a subfolder in your working directory. There's a subfolder called O2 images, and it's a folder that contains about a dozen JPEG files. So what we're going to do is we're going to retype in the MATLAB command for reading and showing one of these images, right? And it's going to be from this location. So let's have a go at doing that. So as we did in exercise 1, let's invoke the imRead function to read that particular image file. All right. So double quotes. I'm going to specify the local folder path relative to where I am. So it's just the name of the subfolder. And then I'm going to type in, say just file 1. Don't forget to put a semicolon. So we're going to read in this file, and we're going to assign the output to a MATLAB variable called capital I. Look, while you're there, let's just display this thing, if that's okay. So show capital I. So if you can just have a go at typing in those two lines, and then click on the light blue bar to execute this block of code. And apparently, I mean, if you also decided to choose file 01.jpg, if that is the file that you chose, there were 12 of them that you could have chosen from. If you chose file 1, then this is what file 1 looks like. All right. Let's just scroll down a little bit further in the script, and let's just pick apart some of the lines that have already been typed in. So lines 19 just confirm that for layer 1, which recall is the image input layer, for that specific layer, there is an attribute called input size. And when we echo the value of that attribute, it tells us that that layer expects an image of this shape. So line 20, we're simply going to assign the output of that, albeit only the first two elements, to a MATLAB variable called input size. So the reason that lines 19 and 20 exist is because we're now going to resize our image. So just like we did in the first exercise, I'm going to create a new MATLAB variable called I2. And I'm going to assign the result of the image resizing to that MATLAB variable. So you might recall that the function that does the image resize is called imResize, and it takes in two input arguments. The first one is the existing image matrix, which was I, and then information about what its resize dimension should be. And this is where I'm going to use that MATLAB variable input size that was created on line 20. Don't forget the semicolon. If you don't type a semicolon, you'll know about it. All right. In finishing off this section of code on line 24, 25, let's again practice what we have already done in exercise 1. Let's invoke the classify method of this network and get it to tell us what it thinks that this image is. So you might recall that it's just the classify method. We specify the name of the network that this method belongs to. We've got a MATLAB object. The name of the object is net. And I have this MATLAB matrix called I2. So run your code and yeah, have a look at the output that gets echoed. For those of you that are sort of at this point, can you just give me a little chat box sort of echo? Just say, yep, seashore. Thanks, Sandra. Thanks, Rashek. Great, great. So look, all we've done is just literally repeated exactly what we did in exercise 1, with maybe just a few more sort of comments about the concept of layers of a network. Layers have unique attributes and being able to sort of interrogate the values of those attributes. So that's kind of new. But the big new thing that I really want to sort of milk out of this second exercise is our file management sort of concept. So if I can just get you to scroll to the next sort of section. So the next section is called run this, presumably the steps that we just did above, but in a loop using a data store. So this brings us to the new thing for this second exercise. So in MATLAB, we have this storage container called a data store. And there are many variants of this data store. There's an image data store. There's a CSV data store. There's an Excel data store. There's an audio data store. We have this concept called a data store. And what the data store allows you to do is to specify a source of where your data is. And in the context of this example that we're playing with right now, we have a folder. We have a folder called O2 Images. And it's in that folder where all of the data that we want to play with resides. So the data store allows us to nominate this source of where our image files are. And then once we've created an image data store and got it to point towards this folder, we can then sort of, manage our data access tasks using the data store. So the image data store is obviously the one that we're going to use a lot today. And some of the methods that the image data store has are listed here. So there's a method in the image data store that answers the question, hey, is there any more data left in the data store for me to process? There's a method in the image data store for reading, reading one of the files that's in that folder. And there's a few more. So yeah, we've got this thing called an image data store. Now let's have a look at how you would use it. So as I scroll to the bottom of this section of code, here's a really nice condensed summary of how we utilize these things called image data stores. So here's the constructor. Here's the name of the class. It's the image data store. We specify just via a simple string the name of the folder where all of our files are. And then, a common task is to automate, the application of a certain, collection of tasks to each file that's in a certain location. So here's how we sort of automate, the looping through each of the files that are in that data store. You'll see that we're sort of controlling the while loop using the hasData method of the data store. You'll see that we're using the read method to sort of, as the way to sort of read a file at a time. And, the output of the read method, it's overloaded with image read. That's all done in the background for you. So we're able to sort of, extract the image matrix. We're then following the same workflow that we just did manually a few minutes ago. We're resizing that matrix to the appropriate size that our network needs. We're using the classify method. Yeah. So look, let's sort of run this section of code. There are only 12 files in this subfolder. It's more than sensible to run it. What I mean by that is we're going to echo, all of the images into the output of the script. You obviously wouldn't do that if you had 10 million images. So as you run this section, just have a look at the output that's been captured by running that while loop. It literally lists all 12 of the images, and in the echo we've added the identified label that our classifier has predicted the image to be, along with a normalized score to indicate how strong that recommendation is. It's normalized between 0 and 1. So I'll let you sort of scroll through the list, and you can get a feel for how our 12 images performed according to just using this pre-trained network. So Seashore, yeah, look, not too bad. Lakeside, yep, not too bad. I don't quite know what conch is, so I can't comment on that one. I do know that that is definitely not a Bernese mountain dog. I know that this is not a bakery, although clearly I can see the association between what I'm looking at and a bakery. So there you have it. I think the bucket is my favorite. There is no doubt that is a bucket, but I'm just questioning whether or not our intention was to identify that the primary sort of thing of interest was the bucket. Okay, so look, let's just rewind, all right, and just take a moment to just have a look at this new thing, all right? This new thing is an image data store, and here's a very sort of common pattern that these data stores are, commonly sort of used with. Okay, does anyone see anything new or different about line 36? So let me just sort of get you to stop and stare. Just have a good hard look at line 36. It's both familiar and different at the same time. So if we look at the sort of the input argument syntax, we specified the network, we specified the resize image, so that's definitely very familiar. But if you look at the output side, you'll see that in exercise 1, we only invoked this classify method with a single output, and that was tell me what this is. Is it a fish? Is it a dog, etc. Here we're actually sort of invoking the classify method with some optional output arguments. Here we're also asking to receive the normalized score. Yeah. So I think this is a really nice sort of opportunity to bring to your attention the MATLAB help browser. I mean, it's one thing to have, 250 functions from the deep learning toolbox library. It is another to know how to find them and what the supported calling syntax of those functions are. So for those of you that have never seen the MATLAB help browser before, let me just spend a minute familiarizing you with that. So I'm just going to the home tab sheet of the MATLAB Desktop. And on the home tab sheet, on the sort of right-hand side, you'll see the round circular icon with a question mark in it. Yeah. So when you click on that circle question mark icon, it launches MATLAB's embedded help browser. And you can kind of think of the help browser as a blend of a web browser as well as a digital user's guide. So, there's a search box. I'm going to just type in just some keywords of interest. Deep learning classify. All right. I'm going to hit enter. And the help browser, it goes away and it reports back to you a whole bunch of hits. Yeah. Just like a web browser does. Yeah. And, built into it on the sort of left-hand side is, you can apply sort of, various filters to sort of, try and filter out, the results. I guess just sort of trying to sort of converge to, something that I want to draw your attention to is when you do know the name of the function that you want to know a little bit more about, then just type in the name of that function, classify. And what I want to do is I just want to show you what a typical doc page looks like for a function or method in MATLAB. So the one that I'm just sort of scribbling on screen right now is the classify method. There are many of them. They've been overloaded with quite a lot of things, but it's the classify method that is, appropriate to what we're doing today, deep learning with images. So I'm going to just click on this guy. And here's an example of a documentation page, for a function or a method. You sort of see that it sort of summarizes, what the allowed calling syntax for the function is, and then it also sort of designates what the input arguments are, what the output arguments are, and then for each of those permitted usage modes, you've got further commentary. There are hyperlinks littered through this. So if I just sort of scroll down to, that second output argument calling usage mode, and if I click on the scores link, it sort of jumps to the section in the page that sort of tells you what this second optional output argument is going to be. Now, a big sort of benefit of really trying to leverage this help browser as much as possible, especially during your early days with MATLAB, is that built directly into the help browser, directly into these function help pages, are examples. And when you click on the example, it shows you a bite-sized chunk of how to use this particular function. So let me sort of click on this very first example. So here's a series that just shows you exactly how in the context of developing a deep network for image classification, how you sort of utilize the classify method. So bottom line on top is if you've never seen the MATLAB help browser, yeah, check it out. Now, there was another reason for wanting to do a pause and ponder here, and that is I'm going to keep the help browser sort of minimized. So, as per normal sort of Windows operating systems, I'm just going to click on the minimize sort of icon. And where it has gone in this MATLAB Online is it's actually been collapsed or minimized down here. So in just a moment, we're going to be launching additional apps. And sometimes I might minimize an app so that I can get back to my screen and see what it is that I want to talk to. When I minimize stuff, this is where the minimization occurs. And if you click on that little icon, you can then sort of select the minimized thing to bring it back. Okay, so look, I think we're done with this second exercise. So let's tidy up. Let's clear the workspace. And let's get ourselves ready by navigating into folder number 3. So if you can just sort of go to deep learning exercises and then choose number 3, MNIST. Okay, and again, if you've got yourself here, then you should see this. Okay, so look, this is where we need to be. Let me sort of bring up PowerPoint, and I'll just start to sort of frame what we're going to sort of talk about next. And that'll lead us directly into this third exercise that we'll do together. And spoiler, this one is really cool because we get to use this thing called the Deep Neural Network Designer. Okay. All right. So the start of this next story is using pre-trained networks is a great idea. And in the topic that comes after this one, when we talk about transfer learning, you'll really appreciate these pre-trained networks. But what I want to talk about in this next example is, well, you know what? Sometimes you're going to have to build a deep network from scratch. So I'd like to talk to you about this particular problem. Yeah. So as you've already seen from AlexNet and GooglyNet, these CNNs, these convolution neural networks, they can have hundreds, thousands of layers. And there are many, many different layer types. So I just want to talk specifically about 3, all right? Just 3 really common ones. And those are the convolution layer, which are, sort of the sort of engine room of these CNNs, obviously, convolution. I'll talk about, one of the acknowledged sort of activation functions, which is a really good activation function to use. And then I'll talk about subsampling, and there are different subsampling. There's average pooling. I'm going to talk about the one specifically today called max pooling. These are 3 different types of layers that you'll encounter in a CNN. So the whole point of the convolutional layer is to create filters, sometimes referred to as kernels. And then those filters are passed across, raster style scanning vintage across an image. And then, a correlation or convolution of that image filter is done with, the target image that's being processed. Yeah. So, here's just a really quick sort of video to say, well, if this was one of the convolution filters, right? If this was a convolution filter, then the thing that we're going to do with it within this convolutional layer is shown by this animation. That is, we take that filter and we sort of apply it, compute, and then shift, apply, compute, shift. And you're seeing examples here of both a horizontal and vertical stride pattern. How far do we move horizontally? How far do we move vertically? So, applying the filter to the image and capturing the results, that's part of what the convolution layer does. Yeah. So the whole point, sorry, if I just sort of go back, one of the sort of learning outcomes of training a convolution neural network is to determine, what exactly these filters should be. So, when you train a CNN, one of the things to come out of that training process is to say, okay, I have 10 of these filters within a designated layer. What values, question mark, what values should these filters have? And the answer to that question is accomplished by training the CNN. Yeah. All right, so in MATLAB, the low-level function in MATLAB that produces one of these convolution layers, it's called convolution 2D layer. And here's a screenshot of the doc page. And when you create a layer using this function, there are dozens of attributes that you can specify. And here's on the right-hand side of the screen is a shot of some of those attributes. So here's an example of an attribute that sort of corresponds to something that's referred to as a hyperparameter. So before you start the training process, you will specify for a particular layer, a convolution layer, how many filters does that layer have? So this is an example of a hyperparameter. Yeah. Another example of a hyperparameter is, what size is the filter? A few seconds ago, we looked at a filter that was a 3x3. Maybe you want a 5x5. So here are some examples of hyperparameters. So just before that thread disappears, I mean, as I'm assuming most of you know, is hyperparameters differ obviously to model parameters. So in the context of your CNN, of your convolution layer, a model parameter would be the values of the filters themselves. Yeah. So you'll hear model parameter, you'll hear hyperparameter. Yeah. Okay. So just some commentary about activations. So typically once the convolution layer does its thing, applying, the filters, and it has a whole bank of these filters, and it produces, outputs. We want to take the outputs from the convolution layer, and we want to pass them through an activation function. When I was a kid back in the early 90s, it was the tan function, the sigmoid function, that was all the craze. But in the last sort of decade, this particular activation function called ReLU, rectified linear unit, it's become really popular because it's really successful. It's amazing that it does, because if you look at it, it does an incredibly simple thing. It simply takes an input, and for any negative values, it just saturates those negative values to 0. And for any positive values, it just passes them through. Yeah. So that's what the ReLU activation function does. The third type of common layer is the subsampling. And there are many different techniques for subsampling. One of them is this concept called max pooling. So real quick, if this was an input matrix to the max pool layer, then what we'd do is we would take a kernel, perhaps it's just a 2x2, and we would say for that region, that 2x2 region, what is the maximum value in that region? And then the answer to that would be, the output. And then we can sort of, slide that sort of, that region of interest filter, either a certain distance horizontally and then ultimately a certain distance vertically. And then, after sweeping across, that input matrix, we would get an output matrix, which in effect is a, in quotes, down-sampled version of that input matrix. Okay, so look, that was a real quick summary. I hope I haven't embarrassed myself and you're probably just rolling your eyes and saying, look, I already knew all of that stuff, get on with it. But anyway, if you're sort of new, they're 3 of the common layers within a CNN. Okay, so a little bit more about what to expect. So as I sort of stated in the intro, the beauty of these deep neural networks is that you can think of them as having 2 distinct parts. One part is called the feature learning part. And this is where you push the raw image, the raw JPEG matrix into the beginning of the network. And then the training process starts to train and to learn features. And in the context of what we've just gone through, it's determining what values those convolution kernels should have. Yeah. So there's the feature training part of the deep network. And then towards the very end of the deep network is what's typically referred to as the classification part of the network. And typically, this classification sort of segment of the network, it typically has three types of layers. It has a fully connected layer, right? So that's the type of layer that you traditionally associate with a shallow network. It has a softmax layer, which then takes the outputs of the fully connected and then converts the values of those fully connected outputs into normalized units. So the outputs of the softmax layer will be values between 0 and 1. And then the final sort of layer is the association of those normalized scores to text labels like dog, fish, hot dog. So that's real rough. The anatomy of a deep neural network. So once we define a deep neural network and we go through the process of training it, you'll hear the term model parameters. Well, I've already sort of discussed that. An example of a model parameter would be, say, the kernel values. And we also have hyperparameters, which are things like how many filters, what size filters. Another nice example of a hyperparameter would be the type of regularization that you use during the optimization algorithm that is involved in training the network. Yeah. Okay. All right. So look, I just want to sort of stop talking and get hands-on one more time. So our third example is, it's going to bring a smile to your face because this is another one of those classic Hello World case studies. We're going to look at the very famous MNIST hand-digit classification problem. So let's jump in and let's start working it. Okay, so I'm hoping that everyone is here. And again, I'd like you to open this work file. So if you can just sort of open the work MNIST script, please. Okay. Alrighty, I'm hoping that this is what you see. So let's just work through it section at a time. All right. So are you in the current directory? Well, let's make sure we execute this section, and you should just get a yep. Well done. So please run. You definitely need to run this section. Okay. Assuming that everyone was able to do that, let's move on to the next section. So we're not going to actually use an image data store to manage this. There are quite a few sort of samples. We have 60,000 training images. We have 10,000 test images. But the size of the images are really small. I think they're only like 28 by 28 pixels. And all of these 70,000 test images actually loads quite comfortably into most computer sort of memory. So let's just run this second section, and you will see after running that section. So please run this. You'll see that it's created for us some MATLAB variables. All right. So one of those MATLAB variables is called IMG data train. You can see that it's a 4-dimensional matrix, 28 by 28 by 1 by 10,000. And there's also another MATLAB variable called image data test. So image data train, image data test, it's a 4-dimensional sort of array that contains our image matrix values. We've also got some categorical sort of arrays, again, correspondingly 60,000, 10,000. And these contain, the actual label data set. Was the hand digit a 9? Was the hand digit a 4, etc.? So this is our training and test data set. If you want to know what exactly some samples look like, let's run the next section. And here's kind of a just a montage of examples of what these handwritten sort of Hindu Arabic digits look like, right? It's 0, 1 through to 9. What we're going to do is we're going to develop from scratch a network to try and correctly classify each of these handwritten digits. So that now brings us to what I think is one of the highlights today, and that's sort of introducing you to an app called the Deep Network Designer. So let me sort of get you to open the Deep Network Designer app. You'll find it by clicking on the Apps tab sheet of your MATLAB Desktop. And when you expand the Apps drop-down box, I just want you to look for a category of apps called Machine Learning and Deep Learning. And I want you to click on this app right here, Deep Network Designer. So just have a go at launching that. Again, if it's the very, very first time that that this is being loaded into memory, it sometimes can take like 20 seconds for it to launch. All right, it's coming. You're getting a sneak peek as to what it looks like, and there should also be a start screen that pops up. Yeah, a start page. All right, so if you've got yourself to this stage, folks, yes, I mean that you will see this little box with an animation going that way. Just get yourself to this stage, please. And if you just sort of click to the, well, on my screen, it's the white bit of the screen. If you just sort of click on that white bit of the screen, all right, it brings to focus the start page. All right. Now, the start page, it gives you the option of loading in pre-trained networks, but that's not what we're going to do today for this exercise. We're going to load in a blank network. So if you can just sort of find the blank network, position your cursor somewhere in the middle, you'll get a button, a blue button, and just click on that blue new button. And here she is. Here is the Deep Network Designer. You know what? I'm just going to try and position my part of the screen. There we go. That should do me. You're welcome to do this as well. I'm just trying to sort of rearrange things on my screen so that I don't need to bounce from minimizing the app, looking at the screen, bringing the app back. Okay, so the Deep Network Designer, it allows you, I guess the sort of tab sheets on the Deep Network Designer give it away. It allows you to manually design a network. It allows you to specify what data you're going to use to train the network. And it allows you to specify training options and to actually train the network. So for this exercise, for this MNIST exercise, we're only going to swim in this pool. Yeah. So what the designer part of the app does is you'll notice that on the left-hand side of the Deep Network Designer, there's a library of layers that you can use to populate your network with. So real quick, you'll see there's a group of layers called input. They're all colored blue. There's a group of layers called convolution. They're all colored yellow, and so forth. Yeah. And as I just sort of quickly skim, yes, you would expect a category of layers called activation, absolutely. Pooling, yep, heads up, we're going to be definitely using something from the pooling category. All right, so what we're going to do is we're going to construct from scratch a network that has this structure. So it'll have the image input layer, it'll have one of the convolution 2D layers, we'll use an activation layer, we'll do our max pool downsampling. So this, if you will, constitutes the feature extraction part of the network. And then the second part of the network is just the fully connected softmax and classification output. So once we sort of drag these layers and wire them together, let's do that first. And then we'll rewind and then we'll configure three of our layers, or 2 of our layers. Okay, so that's what we're going to do. Let's do it. So if you just make sure that you've got the input category of layers on screen, just click on the image input layer. It's the very first blue one, and just drag and release. So that's the very first layer. The second, and look, you're probably already running ahead of me here, and that's fine. The second is this convolution 2D layer. It's from the yellow colored set of blocks. We need one of those. The third layer is from the activation library. So just scroll down until you can find the activation library. There it is. ReLU, that's the particular activation function that we want. Just drag and drop. Now we need to find one of those pooling blocks. Just keep scrolling until you find, I think it's purple. So once you've found the pooling category, look, max pooling 2D layer. So there's a couple that have a very similar name. Just choose max pooling 2D layer. All right, and yeah, look, please, by all means, try and finish the last 3 layers on your own. You'll need to go to the yellow category to find a fully connected. Here it is, the yellow library, fully connected. Softmax, I think that library is sort of towards the bottom of the list. Sure is. Let's get one of these softmax layers. And conveniently, the last layer is also from this output category. It's called the classification layer. So I'm hoping that everyone had some success sort of finding those layers and just dragging and dropping. Once you've got the layers on screen, you just need to sort of wire them together. So to wire a layer together, just bring your mouse towards, say, the bottom of a layer, and you'll see it reveals like a little circular port. And when that circular port reveals itself, just click down and then just drag the cursor until it finally clicks to the destination layer that it's feeding. You just need to repeat that process. So I'll let you sort of do that. I mean, yeah, look, you could spend a bit more time sort of making it pretty, just trying to sort of resize everything on screen, but look, time is against us, I'm afraid. Now, right now, I'm gonna guess, I'm gonna take a punt that some of you from, say, the sort of Python community might be shaking your heads and saying, dude, you know, if I need to construct a 150 layer network, there is no way I'm gonna sort of manually drag and drop blocks, you know, for a 150 layer network. And I think that's a valid statement. But to you, I would say that very soon when we start the transfer learning exercise, the value of a tool like this is that you can load in your 150 layer existing googly net, and then you can graphically prune off the last 3 layers, manually drag in the final 3, and configure it. So to you, I say, there are a number of, genuine use cases where this manual graphical network assembly workflow, it's quite a nice one. Okay, so look, I'm going to guess that you all have your network laid out, wired together. Now let's configure it. So the very first sort of configuration setting is for the image input layer. All right, so we need to configure. So if you click on the image input layer, you might need to just resize your app just to sort of make some of these panels, bigger so you can actually see them. When you click on the image input layer, you'll see on the right-hand side a short list of settable attributes. And what we want to sort of do for the input size is specify the input size to 28, 28, 1. So just let me sort of confirm that. Yep, 28, 28, 1. That's exactly what we need to do. So if I just click on the image input size dialog box, 28, 28, 1. So that's the first sort of layer that we need to configure. The next one is the one below it, the convolutional layer, right? So here we specify the number of filters and also the filter size, yeah? So I think from memory, we want 5 filters, and I think we want filters to be 5 by 5. Let me just double check that. Oh, wrong. So here are the 3 settings that we need to configure. So we need to specify that the filters are 5 by 5. We're going to specify that there are 20 of them. And there's another attribute called how do you want to treat padding? And the answer to that question is we will have 0 padding. All right, so there are 3 things that we need to configure the convolution layer with. I think I can remember that. So click on your convolution layer, find the filter size attribute, type in 5, 5. The number of filters, that was 20. We want 20 of these kernels filters. The padding attribute, it's not an edit box, it's just a drop down. And just choose 0, 0, 0, 0. So that's the convolution layer configured. I think the last layer that we need to configure is the max pool. So for the max pool, we just need to specify that the pool, the size of the pooling filter, it's 2 by 2. And the horizontal and vertical stride, it's also 2 by 2. That should be pretty easy to remember. So click on your max pool layer and just click that in. So pool size is 2, 2. Stride is also 2, 2. So if you're playing along at home, I'm hoping that you've got to this point. Workflow, just find the layers of interest, drag them in, wire them up, and then configure relevant attributes of specific layers. Now, from here we can start using the Deep Network Designer app in a number of ways, and we will elaborate on those different ways in the next exercise. But for this exercise, our next step is, first of all, let's click on the Analyse Network icon. And you can kind of see that in the background, it's sort of brought up that familiar looking Analyse sort of graphic. It's revealing the 7 layers in the network. And if you just do an eyeball of some of the metadata that's being reported, hopefully this is all stuff that you recognize sort of typing in. So if that's what you see, good job. Okay, so just bringing the Deep Network Designer back. So the next thing that we're going to do is we're going to export this network to the MATLAB workspace. So I'll just get you to click on this icon and then choose this Export Network to Workspace choice. And hopefully you've got a whole bunch of green sort of dialogues pop up saying, yep, successfully exported. Please don't close out, don't exit the app, just minimize it because I'll come back and do some further commentary on it in just a second. So let's get our desktop back to how it used to look. So just real quick for those of you that didn't catch that, I've just gone to the Home tab sheet, Layout, Default, and that hopefully brings all of the panels in the desktop back to how they were. So the thing that I sort of want to point out is what was exported from the Deep Network Designer is a MATLAB variable. And the name of that exported MATLAB variable is probably the same on your session. It's just called layers_1. And it's a MATLAB variable that contains these 7 layers that we've just sort of configured. It's not a network yet because we haven't trained it. It is simply just a collection of layers. Yeah. So this is the thing that was just exported from the Deep Network Designer app. Layers_1. Okay, so getting back to the script now, here's, just stay with me, you do not need to execute this section of code. Rather, this is simply bringing to your attention that here is the programmatic equivalent of what we just produced together using the Deep Network Designer. The layers_1 variable is in effect this thing, right? It's an array that contains, the 7 CNN layers. Okay, so let's get down to the next section, all right? And that's called Set Training Options and Train. So before you start the training of your network, there's a whole bunch of hyperparameters that you are able to configure. Things like regularization, what the mini batch size is, how many sweeps through the entire trainings data set you want to do, the max number of epochs. There's a whole bunch of things, yeah? So the function in MATLAB that allows you to specify those hyperparameters is this function called training options. And yes, if you were to bring up the MATLAB doc page, it would document all of the attributes that you can configure, using this function. So line 22, let's just uncomment line 22, all right? And let's finish off the assignment of this local MATLAB variable max epochs and give a value of 4, yeah? So just explaining this block of code, we're going to invoke the training options function to create a MATLAB variable called options that has embedded in it all of the hyperparameters that we want utilized when we finally invoke the training function for our network. So that's what that cluster of code does. Which brings us now to line 28. So line 28 reveals the name of the MATLAB function that trains your neural network. And it just happens to be called train network. Yeah. So you'll see that there are 4 inputs that we need to specify. Yeah. So the very first input is the is the training data set, all right? So you'll see that in the MATLAB workspace, we already have a MATLAB variable called image data train. So we just need to specify that as our first input argument. We also need to specify as the second input argument, the MATLAB variable that contains our labeled response data. And for the training data set, that's called labels train. That's another existing MATLAB workspace variable. Argument 3, yep, that's the name of the array that contains our layer definition for the network. And we've already established that that's called layers_1. So that's argument number 3. So if you sort of just finish off, line 28, and once you've sort of, typed this in, yes, please run just this section by clicking on the blue bar on the left-hand edge. This will probably take about 3 minutes, I'm going to guess. But yeah, let's kick it off now. So what you're going to see over the next minute or so is you're going to see a training progress dashboard. So in just a moment, once the training sort of kicks off, you'll start to see, the progress during each of the mini batch runs, and as we work our way through, the epochs, you're seeing on the top axis the training data set accuracy, yeah. And you'll also see in the bottom axis the sort of loss, the cross entropy sort of loss value while the training is progressing. So, for the network in its current form with the hyperparameters that we've currently used, it performed atrociously. We've done 4 epochs worth of training, and the best we can do with the training set is 10% sort of accuracy. So something I want to call out is that you'll see that while you trained, your training session was utilizing, the cloud GPU, which had been reserved for you today. So that was nice. So this first sort of training run, actually, let me stare at the chat box. Can someone just give me a chat echo to say, yep, training done bad, just so that I can see that you're at the same point that I am. It should be bad for everyone. Don't think that you've done something wrong. Thank you. Thanks, Rashek. Thanks, Aiden. So what you're seeing here is an example that apparently either our network was poorly sort of crafted, or perhaps lower level hanging fruit. Perhaps some of the hyperparameters haven't been sort of specified appropriately. And you know what? That is exactly what sort of happened for this very first training run. So if I go back to the sort of live script, let's just scroll down to the section called attempt number 2. So the reason that that first training attempt failed was one of the hyperparameters, which is super influential in deep network training, was the learning rate. And we just accepted the default learning rate value, whatever that is, in training options. So in our second attempt, what we're going to do, and here's where you need to follow along, is we're going to specify that the initial learning rate is 0.0001. So if you can just sort of edit, sorry, let me try that again. If you can just sort of edit this line of code and make sure that your learning rate is now, initial learn rate is now 0.301. And you'll also need to fill in these pieces. Layers _1 and options. So if you're following along at home, here was the first edit, here was the second edit, and the third. Once you've made those 3 edits, yes, please click on the blue bar on the left to run this code section. You can do that now. I'll just keep this on screen for just a minute longer for those of you that are catching up. Please, but if you're already here, please do it. And what you should see is that over the course of a minute or so, your accuracy for the training data set should be up in that high 80% mark. All right, so let's just look at the echoing that is happening, and you're no doubt would have got the same echoing on your machine. This sort of echo table is just a text version of that progress dashboard plot. One of the columns in the ASCII table is the mini batch accuracy, and you can sort of see that as I sort of scroll to the bottom of this table, that mini batch accuracy is sort of running at about sort of 96.88% on the training data set. Yeah. So that was nice. It would be even nicer if we were able to sort of try it out on the test data set. All right. We'll do that. We'll do that in just a second. All right. So yeah, I guess the sort of takeaway here is, having a sensible learning rate, can definitely sort of influence the success of the training exercise. So yeah, that's good. Let's look at the next section. So here we're going to sort of programmatically define a brand new network, right? So we could have gone back to the Deep Network Designer app to do this, but here's just an alternate way. And the thing to sort of point out in this next sort of version of our network is that we're going to sort of utilize another feature that also has a positive impact on training. And that is we're going to sort of normalize the data that comes out of the convolution 2D layers before it gets passed through our activation ReLU layer. So this batch normalization layer is another layer that you can sort of use to construct your networks. And it really sort of improves in many cases, training performance, training outcomes. So let's just click this section. Oh. So there is a typo. Let's overrule this attribute mini batch size. Let's overrule it with a max epochs, and let's just designate say 4 epochs as the maximum sweep through. So sorry about that. Someone should have fixed this up. So max epochs. I think does it need to start with a capital? I think so. And just specify 4. Once you've made this edit correction, yeah, you should be able to just click on the blue bar. So this one definitely does take just a minute or so. Keeping an eye on that mini batch accuracy sort of column that's just being echoed. Looks like we're getting some strong sort of performance, at least for the training data set. I know you're all itching to say, well, look, hey fella, what about the test data set? Yep, we're going to get there. Relax. Just let it sort of run its course. All right, so at least on my machine, the training has sort of completed, and at least for the training data set, things were starting to look pretty damn nice. All right, but as everyone knows, the proof of the pudding is really when you expose the network to a data set that it's never seen before, and that's the whole point of the test data set. So let's sort of scroll down to the next section. And that's exactly what we're going to do. Yeah. So the network that I've just trained, it's called Net3. So that's the name of the MATLAB object, Net3. Just FYI. What we're going to do is we're going to invoke the classify method for that particular network, Net3. And you'll see that when we invoke the classify method, the second input argument is, our test imaged data set. So this is the data set that the network has never ever seen before. So when we invoke the classify method, it's going to, for all 10,000 examples that are in that image data set, it's going to classify it. Does it think that the digit is a 0, a 1, a 2, all the way up to 9? And then it's going to return those results to this MATLAB variable, predicted labels test. And then line 67 is just computing the overall accuracy. So why don't you run that section? So with the test data set, we were getting an accuracy of about 98.9%. As many of you know, and you're probably screaming at the computer right now, and that is, hey, where's the confusion matrix? That's a better way of summarizing the sort of network's performance. So you're absolutely right. So the function that we're going to use now, if I just sort of bring up the doc page, it's called confusion chart. So I just want to show you what the doc page looks like for the confusion chart function. So in just a moment, we're going to invoke the confusion chart function. The first input are the true labels. The second input are the predicted labels. So this is the if you will, one of the supported usage modes. Some of the optional input arguments that we can sort of specify, for this particular function is that we can ask for a recall and precision sort of summary. So where is it? There's an attribute called row summary, and if you specify a value of row normalized, it'll produce the recall percentages for each class. All right, so let's use it. All right. So if I just sort of hit enter at the end of line 67, let's type in confusion chart. And according to what we just read, the very first input should be the truth, which is labels test. The second input should be the predictions, and that was called pred labels test. So if you wanted to, that's all you really need to type in. But I kind of like having that recall sort of summary. So why don't you have a go at just typing that in and running it. And I guess it's a combination of the real estate. This is a little underwhelming, so I would urge you to click, if you have actually produced the confusion matrix, I'd urge you to click on this so that you get a bigger version of the plot appearing on your screen. So there finally is the confusion chart for the test data set. We have our 10 sort of classes, and what you want to see is that really strong diagonal. And over on the right hand side, you've got that sort of recall sort of percentage metric. And apparently 9 is really hard. So there you have it, folks. We're getting to the point now where we need to sort of wrap up, right? So let me sort of jump into PowerPoint and just offer a few sort of closing remarks. So if that's the first time you've seen the Deep Network Designer, look, I hope you sort of enjoyed it. Unfortunately, time has beaten us. If we sort of had another sort of 20 or 30 minutes, the next exercise that we would have worked on is the one called transfer learning. Now, let me give you just a really quick heads up, because we would have been using the Deep Network Designer app to do this. So the whole sort of beauty of transfer learning is that you can take your GooglyNet, you can take your AlexNet, and you can import it using the Deep Network Designer. And then you can scroll to the very bottom 3 layers and just delete them. Just delete the last 3 layers in Deep Network Designer, and then drag in 3 brand new layers, and they would be fully connected softmax and classification output, right? And that now is your starting point. That will be the network that you then train. And this sort of workflow is called transfer learning. So the benefit that it brings is that you're starting with a network that already has, in quotes, some skills in being able to recognize important things of certain images. And then you're going to subsequently train again, that existing network for the specific set of images that you want to develop a classifier for. And the transfer learning workflow, it is considerably faster from having to start with an untrained network from scratch. So that exercise 4, that would have been, the last exercise for today, and it would have been done completely, with the Deep Learning Network Designer app. Okay, so look, I'm 1 minute away from wrapping up. Nabin, if you're there, I'll do the transfer. So I'd just like to sort of close out with a thank you and a reminder. So again, I'd like to thank Dr. Nabin Sharma for giving us this opportunity today to show you, some of the capabilities, and obviously today was just the tip of the iceberg. Thank you to Dr. Sharma, and thank you to UTS. As a special call out to UTS, just a reminder, if today you are enrolled at UTS as either staff or as a student, undergrad, postgrad, postdoc, if you are enrolled at UTS, not only do you have access to that beautiful all-encompassing campus license of the software, but you also get access to all of the self-paced online training courses. Everyone at UTS has access to these courses. At last count, there was around about 18 of them. So I've sort of lit up 4 that I think you might be interested in. We have a short 2-hour deep learning on-ramp. It only goes for 2 hours. We also have a short reinforcement learning on-ramp. But if you're really keen on knowing, you know, a little bit more, then we have a dedicated machine learning course and a dedicated online deep learning course. And both of these courses have of the order of about 14 hours worth of content. So much like you've done today, these courses present to you a MATLAB online interface. They present static text, movies, and then they ask you to complete tasks in the online MATLAB Desktop interface. And you can put your hands up for hints and solutions. So if you've never seen these courses, they're right there ready for you to use. So I hope that was useful to you and that you got something out of that. So thank you all for your time today. Nabin, if I can just sort of transfer over to you for some closing remarks.
Thank you so much, Bradley. Am I audible, everyone?
Yeah.
Okay. Thank you. Thank you so much, Bradley and Emmanuel, for the wonderful session. I think everyone enjoyed. It was a very very short, but a lot of content, a lot of important information on using MATLAB and using deep learning, how you can train the models and all those things. Thank you so much. Very much appreciate Bradley and Emmanuel for your time. Thank you to MATLAB as well for their support for this for the UTS AI showcase. I also would like to thank our student volunteers who have been managing the Zoom sessions pretty well, and everyone in the organizing committee. Thank you so much. Do we have some time for a couple of questions, Bradley?
Yeah, for sure. You be the time monitor. You shut this down whenever you need to for the next presenters. But yeah, I'd be happy. Emmanuel and I would both be happy.
There was one question on the chat window whether the slides can be shared.
Yes. So I'll PDF up the PowerPoint deck and just send through the PDF file. If I send it to you, Nabin, would you be able to then handle the distribution of that through whatever means is sensible?
Absolutely.
Yeah.
And is it fine to put it on the website as well as a link?
Yeah,
Okay.
absolutely.
I think that would be the easiest way to circulate the slides, I guess. The workshop recording will be available very soon. I think it will be available on the channel instantly, but a better version, a polished version of the recording will be available after the workshop, maybe sometime today evening or maybe tomorrow. If we have any other questions, please feel free to ask. We have just a couple of minutes more before we wrap up the session.
Great. Look, I have a question, but I'm not going to ask mine until someone's had their opportunity. So if you've got a question, don't be shy.
Any questions, anyone? You can put it on the chat window, or you can unmute and speak. That's fine. Okay, Bradley, I think you can ask the question.
Okay. Yeah. So look, my question is, I see that we've got approximately sort of 30 attendees, give plus or minus 1 or 2. So
Yeah.
I'd be curious just to sort of get a sense for who is using MATLAB today for either traditional machine learning or even for the deep learning sort of problems. Who's using MATLAB based stuff for your AI projects? If there's some way you can just sort of give me a shout out in the chat box, I'm just curious. Yes.
So for 1 year, yeah.
Yeah, thanks.
Coming up.
Thanks, Ian. So yeah, you know what? I mean, that really was the expectation today. That the vast majority, in brackets, everyone, was most likely going to come here from an open source AI framework experience background. So yeah, look, I know we have a tendency to go tribal when you have these conversations, But you know, certainly the remark about being able to utilize the Open Neural Network Exchange format as, you know, one of the ways to sort of, you know, transfer MATLAB-made stuff into your Python world and to get Python-made stuff into the MATLAB world. It doesn't have to be all just us or all just, you know, Python. You know, in a sensible world, picking the strengths of both, and, you know, being aware of the strengths of both. I mean, whether you're comfortable with this or not, but people that make planes, trains, and automobiles, they are using MATLAB stuff for very exciting AI projects. Whether it's, you know, drift identification on BMW M4s, or you know, Tesla sort of, you know, automated driving systems. MATLAB is being used in these AI projects, so it's not like we're a foreign entity for these sort of applications.
Wonderful. I think all good. We can wrap up the session, I think. Is that okay, Bradley?
Yeah, thank you.
Okay. Thank you so much, Bradley and Emmanuel, for your time today. And it was a wonderful session. I would also like to thank MATLAB for helping us with this workshop and also sponsoring some of the prizes. Well, due to the COVID-19 situation, we were not able to meet on campus. This workshop was still scheduled as a campus event, but due to the current situation, we had to, you know, rapidly move everything into online delivery mode. But I think everything is fine now. We have done the workshop. We have a couple of more sessions coming up in a few more minutes. And additionally, the UTS AI showcase, particularly the project ones, will be happening on campus once everything is back to normal or near normal, and we are able to have the event on campus. So please check out the websites, the showcase website for details on the new dates. We'll also receive a notification from the organizing committee very soon on the new date. Thank you very much, everyone, for joining us today for this wonderful workshop. And thanks again to MathWorks, Bradley, and Emmanuel for running a wonderful session. Thank you, everyone, and have a wonderful day.
Thank you.
Thank you.
Thank you. Bye-bye.